Okay, welcome to the online class on electricity bill calculation. Okay, so now today we are going to learn about. Okay, hope everyone is able to see these devices. So this is nothing but an bulb. We'll try to calculate the power consumed by this bulb, and this is an mobile phone charger. Let us try to calculate the power consumed by this adapter. Okay, so let's try to understand the things better to make the electricity bill calculation. So before doing this, let's try to calculate your electricity bill. So you have multiple appliances in your home. We need to calculate the energy consumed by these appliances. Okay. So we need to define, so in order to do all these things, we need to define what is meant by one unit of electricity. Okay. So what is 1 unit of electricity is if 1,000 watts of load is you consumed and it is operated for a time of 1 hour, then I can call this is going to consume. So this 1,000 I can write down it as kWh. 1 kWh is equal to 1 unit of energy consumption. Okay, so this is going to consume 1 unit of energy consumption. Okay, so this is how we define 1 unit of electricity. If 1,000 watts of power is consumed in a time of 1 hour, then I can say that 1 unit of electricity has been consumed. Okay, so this is how to define the rating. So in electricity bill calculation, first we need to calculate the power rating of the devices. Okay, so if you take a basically a bulb. Okay, so this is nothing but an bulb. So on this bulb, here you can see here the bulb. Here you can directly observe the load. So the bulb rating is 9 watts. Okay, so it is of 9 watts, and the voltage rating is 230 volts, and the power factor on the bulb is given as 0.9. So this bulb is nothing but an AC bulb. So therefore the formula for power P equal to VI cos phi. Okay, so what is the formula of P is nothing but 9 watts is equal to 230 volts into I into the power factor is 0.9. Okay, so when you do it your calculator, so here you can see this rating of the bulb is given as 9 watts, and the power factor is 0.9, and operating frequency is 50 hertz. Okay, so when you calculate, so you can verify the current drawn by this bulb, which is nothing but 9. Okay, so which is 9 divided by 230 into 0.9. Okay, so when you do this product, then you are going to get the current as so the amount of current that is drawn by this bulb is 0.0434 amperes. Okay, so this is the amount of current drawn by this bulb when you are turn it on. Okay, so this is how the power rating of a bulb we can decide as 9 watts, voltage is 230 watts, and consuming current of 0.043 and operating with a power of 0.9. Now let us try to calculate the power consumed by this mobile phone charger. Okay, so here you can see here the wattage is not given, but voltage and current is given. So let's try to calculate what is the power rating of an charger. We don't know the charger power rating. Let's try to calculate. So on the specification, here you can see here, it is defined as the output voltage is approximately 5 volts. Here you can see carefully, it is 5 volts. So voltage is of 5 volts, and it draws a current of here you can see here it draws a current of 6 amperes. Okay, so 5 6 are is nothing but 30 watts charger. So this is a 30 watts charger which consumes the power. Therefore the power rating of this is 30 watts. In the upcoming video I will be showing you about so what is this residual current circuit breaker and how this RCCB will work, and this is called as a portable residual current device. Okay, so how it operates and how it is useful to us, I will discuss in the upcoming class. This is a very interesting video where which will be useful for you. Okay, so these are what we are going to discuss in this class. Okay, now let us try to calculate the power consumed by an home appliances. Okay, so let's try to have a tabular column. So now we are going to calculate power consumption made in a home. What are the different power consumption at home? So first one, let's try to segregate. So first one is the type of appliance. Second one is how much amount of load. It is nothing but the power rating in terms of watts, and number of equipments. I mean number of loads are there, which is nothing but the number of equipment. Next one, average hours you are operating that per day. Okay, and on our average, now we are going to add. So the next one is approximate units per month. Okay, so approximate units consumed per month. Okay, so let's try to take the first appliances is lamp. So first appliances is lamp. So this is nothing but this lamp. Okay, so if it is an LED, it will consume only 9 watts. Let us take, we are having an incandescent lamp, which is nothing but it is consuming 60 watts. And let's try to take this is operated for 10 hours daily. So number of hours we are operating it as 10 hours, and number of equipment I'm taking it as only 1. So when you take the approximate units, it is consuming per month. So what you have to do is, let us assume that this is a value, this is b value, and this is c value. Okay, let us try to calculate per day, and later on we'll multiply the day into 30, then you'll get number of months. Okay, so now let us try to see here. This is the formula here is nothing but so first one, wattage into the quantity, which is nothing but quantity, which is nothing but b value, into c is nothing but hour. So therefore you are going to get the units in terms of watt hour, but the units of energy consumption is in kilowatts. Therefore you multiply this k with 1000, which is called k, and divide with 1000. So therefore this 1000 I can write down it as 1 kWh. Okay, so this how we are going to get the number of units consumed in 1 hour. Okay, now lamp is of 60. So when you multiply, or you can define in a simple layman language. So A is nothing but watts, and B is nothing but the quantity of the equipment, and C is nothing but number of hours. Okay, so here you have got watt hour, but I want in kilowatt. Therefore we have to multiply this with 1000 and divide with 1000. Therefore you will get the units in terms of kWh. Okay, so you multiply it. For example, let us try to do here. So A is of 60 into 1 into number of hours is 10. So multiply this with 1000 and divide this with 1000. Okay, so when you, so this I can write down it as kWh. So 1 0, another 0, this 0 and this 0 will get cancelled, which is nothing but now 60 by 10. So this is nothing but 0.6 kWh is the amount of energy consumed by this load per day. Okay, so similarly, let us try to do the same calculation in the case of an tube light also. So tube light, let us assume the tube light rating LED tube light is 20 watts, and like this we have one tube light, and this tube light is also operated for 10 hours. Okay, so energy consumption, let's try to calculate. So energy consumption is nothing but what? 20 watts into how many quantities are there? One quantity is there. Multiply this nothing but watt. Hour. Hour is nothing but how many hours? 10 hours divided by 1000 into 1000. When you do it, here you can see here this zero, this zero, this zero, this zero will get cancelled, and you are going to get as 0. I mean, which is nothing but 2 by 10, 0.2 kWh are the number of units consumed by this tube light when you're operated per day. Okay, so similarly let us try to calculate the power consumed by different loads. So we have an table fan. Okay, so our table fan will consume, or let us try to take the ceiling fan. Okay, so ceiling fan is of 60 watts, and I have one quantity, and it is operated for 10 hours. Just multiply all this 60 into 1 into 10 into 1000 divided by 1000. Okay, so then automatically you can get, which is nothing but this is also 0.6 kWh. Like this you calculate the power consumed by different equipment. So similarly let's try to calculate the power consumed by our music system, which is nothing but when you have when you have this TV speakers, external speakers, this is going to consume 1000. And let us take we have only one, and this is also operated for 1 hour. Okay, so like this the different power consumed by different equipments. TV, so if you have an LED TV, so of 40 inches, it is consuming for 90 watts. And you can have the quantity you can define, and how many hours you are going to operate this TV also you can write down here. Just do the product of watt quantity into hour and multiply this quantity with 1000 and divide this quantity with 1000, then you are going to get the number of units consumed per day. Okay, so similarly you try to calculate so the next load is nothing but grinder. Okay, so or the mixer, where this mixer rating is 500 watts. And the next load we are having, which is nothing but the iron box, and this iron box is also going to consume 750 watts. And the next equipment we are going to have is a refrigerator, and refrigerator is also going to consume 150 watts. And the next equipment is nothing but the immersion. I mean, we have geyser type, and we have the immersion rod. This is going to consume approximately 1000 watts. So 10th equipment is nothing but what generally we use daily is nothing but washing machine. This washing machine is going to consume approximately 750 watts. And let us try to take, we have a 10 liters geyser. Okay, so a 10 liters geyser is going to consume 2000 watts. And the next one we have an micro oven. So if you have a micro oven, this micro oven is also going to consume 2000 watts. Okay, so micro oven quantity is 1, and number of hours you are going to operate is 1 hour. So therefore how to express in kWh is 2000 watts into quantity is 1, and number of hours is 1 hour. So multiply with 1000 and divide with 1000. So this thousand will get cancelled out, and this is going to consume 2 units per day. Per day it is going to consume 2 units, and if it's operated for a time of 1 hour. The next equipment we are going to discuss the power rating, which is nothing but micro oven. And next one is air conditioner, which is of 1.5 ton. Okay, so this experiment we have in the lab. Okay, electricity bill calculation for domestic appliances we have in the lab. The same procedure you can learn indirectly. Now we have learned the lab. Okay, so air conditioner is of 1500 watts, one quantity operated for a time of 1 hour. Then automatically it is going to consume 1.5 kW, I mean 1.5 units it is consuming per day. Okay, so next one, coming to the after AC, you are going to have an computer. Okay, so computer or laptop, so this is going to consume 100 watts, and 1 hour, let's assume that we are running it for 10 hours, multiply the and do the kilowatt hour. Okay, the next one, you are having an printer in your home. So printer is going to consume 150 watts. And 16th one, you are going to have bread toaster. Okay, so in foreign countries we have this toaster, bread toaster, and they are also going to consume approximately 750 watts. And 17th one, we are going to have a immersion. So those who are bachelors will know about this immersion type of heater in this winter season. They are also going to consume approximately 1000 watts. And next one, municipal pump. So what we get the water from municipality. So this is nothing but municipality pump for drinking. So this is of 7 HP, which is nothing but 750 watts. And 19th one is nothing but a charger. Okay, mobile phone charger. So this is going to consume, nowadays we have 50 watts charger, and one quantity operate for a time of 1 hour. So when you add all this last column what you have got in kwh, you add all these values, and you'll be getting, for example, let us assume that I had got 100 kilowatt hour. I mean, I had got 10 kWh per day. So per day I'm going to consume how many units? 10 units. So I want to calculate it for month. So how to convert the month in day into month? So 10 units per day, and like this per month how many are there? 30 kWh per month. So 10 into 30 is nothing but how much? 300 kWh. I mean, number of, I mean, 300 units we are consuming per month. Okay, so what is our electricity bill? We have been obtained by using multiple loads. So we have been obtained around 300 units. So this is how we use it to get the electricity bill. For example, when you take this 300 units, then how do we have to calculate? Let us try to see with an example. Okay, so for the first, so let's take an live example. So 0 to 31 units, which is nothing but so totally for 30 units, government is charging us 1 rupee 90 paisa. Okay, so and next one from 0 to 30, 31 to 75 units, it is going to charge as rupees 3. And from 76 to 125 units, then it is going to charge at a rate of 4 rupees 50. So this I am saying about the tariffs in Andhra Pradesh electricity bill. So next one we have 126 to 225, then we have to pay approximately 6 units. Okay, so next one 225 to 400 units, if you are consuming, then you have to pay approximately 8 rupees 75 paisa. Okay, so this is what the bills are. Okay, so now let us try to see here. So here the number of units you are going to bill it for 30, and here you are going to get it for 45, and here you are going to get it for 49 units. Just you take the difference, then you can understand. So 70 to 125. So 125 minus 76. So then you're going to get 49 units. So here 225 minus 126. So here for 99 units you're going to get like this. So for 300, so okay. So now 300 minus 225 if you make, then you're going to get 75 units. Okay, so now let us try to calculate how many units we have to get. So totally here in 30, so total we have to calculate for 300 units per month. So first 30. Okay, so 30 plus 45 plus 49 plus 99. So when you do it, when you add all these things, we had got 223 units, and we had got how many units? 300. So when you take 300 minus 223, then here we are going to get how many units you are consuming in this lab is 77 units. Now let's try to calculate how to do your electricity bill. So let us try to see here. So the electricity bill we will get in Andhra Pradesh government is first one. So for first 0 to 30, how much? So 30 units into 1.9. Let's try to take it as 2 plus next one. Next 45 units, they are charged at a rate of 3 rupees plus next 49 units, they are charged at a rate of 4.5, and next 99 units, they are charged at a rate of 6, and next 77 units, they are charged at a rate of 8.75. You do with your calculator, then you are going to get these values. Okay. So this is 30 into 2, which is nothing but 60. So 45 into 3, so which is nothing but 135, this value. And this one 49 into 4.5, so this is 220. So those are in online, please check it out and send me the resultant answer. 99 into 6, therefore you are going to get 594 rupees plus 77 into 8.75. When you do it, then you are going to get 673.35. So add all these values, then 60 plus 135 plus 220 plus 594 plus 673. So
3,000.
no, it's wrong. You have done. Okay. So 594 and 693. Overall, you are going to get 1682 rupees. So those are in online. You please verify whether this is correct or not. Okay. So like this. So when you are getting 300 units per month electricity bill, then Andhra Pradesh government is charging you approximately, you will get an electricity bill as 1382 as a base, and there are many number of charges which are nothing but FCCP charges, fuel and power variable charges. I mean flexible variable charges. Then you will get one more 1600. So approximately when you do it, on an average, you'll be getting around 3,282 rupees. You're going to get if you're using these 300 units in Andhra Pradesh government. So this is all about how we get the electricity bill. Now let's try to discuss what are the two types of tariffs. So hope everyone is able to understand. Yes or no?
Yes, sir.
Sir.
Let's have an revision. So what we have actually, this is our scheduled offline class in the class. I think in college, if it is there without band, we might have the class, right? In the same time. Right. So what we have been discussed now is, here you can see here, what is meant by 1 unit of, just everyone turn off your, turn on your mics. Yeah, good. So what is meant by 1 unit of electricity consumption? So what is 1 unit of electricity consumption? Anyone?
1 kilowatt per hour.
Yeah. So if you are consuming 1000 watts of power in 1 hour, then I can say that we have been consumed 1 unit of electricity. So what are the, how to calculate the power rating? Either power rating will be directly printed or current will be printed. Okay. And voltage defaultly, in we are in Andhra Pradesh, then 230 into that current multiplied with power factor, then you'll get the power rating. So what are the different appliances power rating? What is the power consumed by an LED lamp? So I've shown you an LED lamp. What is the power consumed by this lamp?
60 watts.
So 60 watts. This is an incandescent lamp. If it's an LED lamp, it will consume only 10 watts. Okay. So how to calculate the number of units consumed by an load? What is the formula? What is the formula to calculate the number of units consumed? Watts into quantity.
1000.
Yeah, into quantity into
number of
hours
hours consumed.
into 1000 by 1000. Then we can
1000.
calculate number of units we have been consumed per day. Okay, so like that, what is the power consumption of a tube light? LED tube light, 20 watts. Okay,
20 watts.
yeah. What is the power
20
consumed by
watts.
an ceiling fan?
60 watts.
60 watts.
So if you
60
give the
watts.
response, no, this you can understand, and the same you can present in the lab also. That's why I'm asking you repeatedly to know the power rating of the load. So the remaining students are not giving response. If you give the response, my mic system should damage. Like that, I want the response from you. What is the power consumed by an music system at your home?
100 watts.
Very good.
100 watts.
Good, super. What is
100
the power consumed by your LED TV 40 inches or 32 inches approximately?
90 watts.
90
watts.
So how to get the number of units consumed per day? 90 into 1 into
One
number of hours.
Quantity.
Yeah.
Number of
Quantity into number of hours into 1000 by 1000. Then you can get
1000.
the number of units consumed per day. What is the power consumed by a grinder?
500
500 watts. What is the power consumed by an iron box in your home?
750
watts.
watts.
So this all will give the power rating. If you see like this at the back, this is a charger. I think it is visible to you. So I want to calculate the power rating of this charger. But here power rating is not given. But what is given? Voltage. You can see in your charger also. Voltage is given as well as current is given. This is a DC type of devices, which is a rectifier. So 5 into 6 if you multiply, then you are going to get a 30 watts. So this is how it charger is consuming 30 watts. What is the power consumed by an iron box in your home?
750
750
watts.
watts. And you do the product of number of quantity into hours, multiply with 1000 and divide by 1000, then you are going to get kilowatt hour. So what is the power consumed by an refrigerator?
50 watts.
150
watts.
watts. Very good, super. Next, what is the power consumed by a normal? You have immersion type heater. So those are bachelors, they'll be knowing what is the power consumed by this immersion type rod. 1000 watts.
1000 watts.
So you should remember this. Why? Because you have an experiment on lab. All this you should write, and all this power rating you should be very clear of that. So what is the power consumed by a greaser? Normal greaser.
2000 watts.
2000 watts. What is the power consumed by a micro oven? So those who have micro oven, you will be doing 2000 watts. Next one. So what is the power consumed by an AC of 1.5 ton? 1500 watts. Good. And what is the power consumed? Now we are doing the work on the laptop, and this laptop is going to consume how many watts? 100 watts. So I am having a
100
printer. How much it is going to consume? 150
150 watts.
So if you have a bread toaster to toast your bread, then it is going to consume approximately 750 watts. And if you want to have drinking water or water to municipality, I mean water from municipal pump, then it is going to consume 1 HP, which is nothing but 750 watts. So like this, all this we have to add. Okay. So what do you understand? What you have to do is you take your electricity bill in this month. Okay, and it will be written how many units you have been consumed, what are the extra charges are there, that will be written on your electricity bill. And you can at the back, if you turn it, you can see this tariff methods. So what is this tariff method, you understand? So already you consume how many units? Let us take that a consumer is having consumed how many units? 300 units. So first 30, what is the billing in Andhra Pradesh?
1.90.
So 1.9, I mean 2 rupees he has to pay for first 30 units. Next 45 units, I mean 31 to 75, how many he has to pay? 3 rupees. So
3 rupees.
from 76 units to 125 units, how much he has to pay? 4 rupees 50
4
paisa. Yeah, 4
5
rupees 50 paisa. So from 126 units to 225 units, how much he has to pay? 6 rupees. Okay.
6 rupees.
So remaining, I mean, if you add all this, the remaining, you are going to get 77 units. In this, he has to pay 8 rupees 75 paisa. So average only for consumption, you are going to get 1682 units, but we have a lot of what is that, consumer charges, consumer excise charges, and FPPCA charges and all. I had made a video. I will share that video for you, where you can understand how we are getting an electricity bill in Andhra Pradesh government. What are the different charges? What are duty charges? Everything had made an video. You can see in that you actually will be getting the 1600 only original consumption, but 1600 rupees extra we are paying from your pocket, in the form of extra charges like FPPCA, two up charge, and different types of surcharges and different types of electricity duty. Then our average your bill is how much? 3200 rupees. So why we are paying this extra? I had made one video. I will share that video. You please watch that video and you will get a clarity, and you can explain to your parents also why we are getting more electricity bill in Andhra Pradesh. Okay, hope you had got a complete idea on how to calculate an electricity bill to our home. Is it clear?
Yes, sir.
Is everyone confident? Can you, if you get this question in the lab exam, can you perform of your own?
Yes,
Yes,
sir.
sir.
So now we are clear.
Yes, sir.
So I want response from everyone. I am expecting response from everyone, those who are listening. Right. So now let us try to discuss the one more type of tariffs. So there are two types of tariffs. So for example, so two-part tariff. Okay. So what is this two-part tariff? So actually this two-part tariff is meant for industries. Okay. So what is this two-part tariff is? So here we are having the two parts. Okay, so total bill, or the total bill you are going to get as, so A into kilowatts, okay, plus B into kWh, where A indicates these are nothing but the fixed charges given by the government. So these are fixed, and B is nothing but variable charges depending upon our units consumption. This B is an variable quantity, but where A is an fixed quantity. Okay, so for example, you are in, we have our campus. Okay, so this kW you are going to, A is nothing but number of units you consumed as per the maximum demand. For example, our college is having a maximum demand of 300 kilowatts, but we will consume only number of units, but you will get the bill for maximum demand as well as the number of units you consume. But this is in the case of an commercial. So our college is commercial, so therefore this bill we are going to get, and the name of this bill is called as a two-part tariff. But in the case of domestic, we don't have this two-part tariff. This domestic is nothing but for our houses or the home. We don't get this kind of bill. We will get the bill multiplied with only B into kWh. This is what I have been saying now. So this year we are multiplying with number of units into how many number of units multiplied with unit cost you are going to get. So here we will not have A, therefore 0 plus kWh we are going to get the bill in the case of an single part tariff, for the case of houses or domestic. For the case of colleges or housing malls or shopping malls, then you are going to get in the form of A into kW plus B into kWh. Okay, so what is it, this way is advantages or disadvantages? So it has a little bit advantages as well as disadvantages. Okay, so if the consumer is not this two-part tariff will help the consumer if he's not paying, if he's not consuming, is not running the industry. Okay, so fixed charges is there, so this he has to pay regularly. And if there is no consumption in the industry, government will refund this amount to the consumer. Why? Because he is connected to that load. So this what one advantage. Similarly, the same disadvantage is here. So for example, we are consuming only B part, but we are paying for A part. So this will increase the monthly electricity bill in the case of an industry. Okay, so this is what happening in an industry. So now industry comes under two-part tariff. Now let us try to see one example. So let us take one small example. So we are having a 3 kilowatt load we are having in our home, I mean we are having in our college, which is 3 kilowatt. And for first kilowatt the government is charging 85 rupees for the first kilowatt, and for the other than, I mean greater than 1 kilowatt, it is charging us 95 rupees. Okay, then how we are going to get the bill is, so the total bill will get for college. And here let us assume that we are going to have around 300, I mean 1500 units monthly. Okay, so when you do this calculation, the total bill what we are going to get in our college is a is nothing but how much. So here we are having 3 kilowatt load. So first 1 kilowatt is nothing but 1 kilowatt multiplied with 85 is first amount, plus so 3 kilowatt, I mean in 3 1 is completed, 3 minus 1 is how much, 2. So the remaining 2 kilowatts multiplied in the charge of 95 rupees. So this is which value? A value, which is billed for the maximum demand. The maximum demand in the college, which is nothing but the maximum demand in the college is 3 kilowatt. And for first kilowatt, we are paying 85 rupees. For the remaining 2 kilowatts greater than 1 kilowatt, we are paying 95 rupees plus. And how many units we have been consumed is 1500 units, which is nothing but b value. Okay, so therefore 1500 units we have been consumed. So when you do the product of this one, then how much bill we may get approximately per day we can calculate. So when you do this calculation, this is 85 plus 95 into 2 plus 1500, and let us take the cost is 10 rupees per unit. Therefore you are going to get 15,275 rupees bill per month. So okay, that's how we are see here. So actually this is only uh, 15,000. Okay, so this is nothing but 15,000, but 275 rupees extra we are paying from our pocket. Why? Because due to this two-part tariff. So they are going to take from the where A is called as a fixed charge, and we are paying for this depending upon the maximum load. So if you have maximum load of 3, then based on this we have to pay. But actually we are not consuming this one. Just government we are paying unnecessarily 275 rupees extra, but how much we consumed is only 15,000. So like this it will be varying step by step. So this is all about the electricity tariffs, which is called two-part tariff. So why it is called two-part means, this is first part and this is second part. So we are billing it for maximum demand and we are billing it for number of units consumed. This is called two-part tariff. So this is all about our basic electricity bill consumption per month. So now we'll discuss about the equipment safety. The first one is fuse, next one is MCB, next one is RCCBs, which are very much important for us to discuss. Okay, so what's the time? So just take a small break for 5 minutes. We'll refresh ourselves and we'll start studying about fuse, MCB, and RCCB, and we'll close the class. So I don't take more than 1 hour. We'll try to close as soon as possible. Try to take a small break. We'll meet in 5 minutes. So okay. Hello. Shall I start the class?
Yes, sir.
Okay. So why multiple breaks are given is have to get refreshed, and the computer also is not supporting too much, and some network issues are there. Therefore, we need to give some breaks to cool the system also. Now let's try to discuss. Shall I continue now?
Yes, sir.
Yeah. Okay, good. Thank you. So now we'll discuss about the safety measures. So hope by this class I will close the third unit of electrical part A, and we will be having we'll discuss in detail part B, third unit, in the normal classes. Okay. Therefore, 100% we can close the syllabus, and the probability of you to pass in the exam also will be 100%. So right. Thank you for your cooperation. So we'll have an sufficient knowledge to pass the exam. So now we'll try to discuss about the electrical safety devices. Okay, electrical safety devices. What are these electrical safety devices or protective devices? Safety or protective devices. What are these devices? Let us try to discuss. So first one, why we require safety device means safety devices are required to protect ourselves or the load from overload. So whenever your mixie is overloaded with chutney, it may burn. So we have to protect our mixer under overload condition. We have to protect our home from short circuit. Why short circuit will happen is you'll be having an transmission line at outside. We'll get the power. So suddenly what will happen is a tree will touch the transmission line automatically. So the tree is connected to the ground, and this may make the current to flow as short circuit. And in this transmission line, so you'll be having the transmission line like this on the road. So some tree may touch it. So a tree may touch, or these snakes will touch these two lines automatically. Short circuit will occur in this, and more amount of current will be flowing, or god will give a gift in the form of an lightning. Automatically short circuit current will flow, and it may damage. So for all these damages, we have to protect ourselves from overload, and we have to protect our home and the appliances from short circuit problems. So in order to design all those, we have been developed some basic devices, which is the first fundamental device is nothing but a fuse, and next fundamental device are nothing but relays. Next device is nothing but miniature circuit breaker. MINIATURE. Miniature means which is nothing but a small sized one. So small sized circuit breaker. Okay. So these are the basic devices we have in electrical engineering to protect from different shock. Next one is earth leakage circuit breaker. What is this earth leakage circuit breaker? we will discuss. Okay, so earth leakage circuit breaker. What is this earth leakage circuit breaker means? Here you can see here, this is an earth leakage circuit breaker. So this earth leakage circuit breaker is designed in such a way that so whenever, so you have two terminals. So 1 second, let me give you an clarity. So hope the RCCB is visible to you all. Yes or no? Please give the response.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good.
Yes,
So
sir.
this is because I can't see the video. Why? Because you have to only give the response. So it is not audible. I mean, it's not visible to me whether I am showing the things or not. 1 second. So hope now we think it is visible, right?
Yes, sir.
So this is called RCCB. So here you have an plug. Okay. So can you say the names of this plug? This is called as earth point. Okay. Here you can see here we have a bigger area. So this is called earth. Okay. So all the time see that the right hand side. So what is the right hand side? I'm having the ring. So this is nothing but the right hand side. This is called as a line. Okay. And it will be written here, which is nothing but L. Okay. And next one is nothing but neutral. So when you are having an, for example, this is called RCCB, and this is designed by the brand Heavils, and this is a life savior equipment. I mean, it protects our life. Okay. So how it protects our life is also very much important. So this will protect our life from shocks. For example, when you insert this plug into an 3-pin socket, and for example here we are having an geyser, or kids may play with these chargers. Okay, so as soon as the kids play with this charger, so output we may connect to an wire. Okay, so output when you are connecting to an wire, what will happen is so people, I mean, when you connect to an charging point, let me show the charging point also. So when you have this 3-pin and when you are connecting with this point, so this is an type C port. So as unfortunately if you touch it, or these children keep this charger in the mouth wantedly or unknowingly, or if it touches any of the component, there's a chance that the people may die. Okay, but when you have this RCCB device, okay, when you have this RCCB device, so this RCCB device will help us to stop the leakage current. As soon as you, if you keep this port in the water, or if you keep this in your mouth, automatically this will trip, and this trip button will come out. Okay, here you can see here there's a trip button, so test button. When you press this button, automatically this will come to off position. Okay, so this is how this RCCB will safeguard the life of the kids, those who keep the chargers in the mouth, or when you keep your charger inside the water, or when you are having a problem with any water geysers or any problem. So if you have this life savior device, never people will die due to electrical shock. So this is a cost of around 900 rupees, and this product is 100% only to protect the life of people. So if you have this kind of device in your home, you will not die. I mean, at any cost. And when you have geysers, in the geyser, water will combine, and automatically there may be chance you may die. Okay, but when you have this kind of devices, water and current will never combine, and never you will die. So that's what the advantage of this device. And these devices are recommended to use at geyser terminal, and these devices are recommended to use at washing machine. Why? Because washing machine is running, water is also combined, and the water will go into the machine, and there will be chance of leakage current. And when you touch this washing machine, there is chance you may die. And this is recommended to use at geysers, water heaters. Okay, submergible water heater types, and you can use this for mixie also. Why? Because you will operate the mixie with a wet hand. There may be chance that water enters into the switch and you may get the shock. And the possible chances of getting shock is your bathroom switches regularly will get the shock. When you install this at the starting of your home, at any cost you will not die. Okay, so these are the called as PRCB plug. Hope the terminals are also visible to you. So how many terminals are there? And this can sense a current. We can use this for an current of 6 amperes or 16 amperes, or and the sensitivity current is 30 milliamperes. Up to here, it can protect us. So indirectly, I can say one thing: if you have this type of RCCBs, 100% you can protect your life from electrical shocks. The shock may be due to leakage current, or the shock may be due to over current, or the short current may be due to leakage current flowing, or when you touch this terminal. For example, if you have this type of switches, as soon as you directly keep your hand inside the plug at the right side also, you will not die. Why? Because it is designed with such safety. We will now discuss about this switch. Hope everyone is able to understand the purpose of this PRCD plug. Yes or no?
Yes, sir.
Yes, sir.
So can you anyone say the application where we have to use this PRCD plug or RCCB plug?
Washing machine. Washing machine.
Where water and
Yes.
current combine. Okay, washing machines.
Yes, sir.
Very
Water
good.
heater.
Water heater. Good. Next one. Water geysers, where water and current will combine. And mixie also we can use. For example,
Yes.
your what is that, laptop charger is there. Okay, when you connect the
Water
laptop
pumps.
charger like this, so kids may be there in your home and they will take this port and they'll keep inside their mouth, and there may be chance many kids are dying due to this kind of shock. You can avoid all these shocks just by using this RCCB device. Okay, so this is available in online. If you want to purchase also, you can purchase it. And this very life-saving device, that's why it is written on the table. You can see here, it's an lifesaver. Is it visible? I think clearly
Yes, sir.
now it is
Yes,
visible.
sir.
Okay, when you connect it, you can see the things very clearly. So now about this device we are going to discuss now, which is called as a earth leakage circuit breaker. Okay, so this is called earth leakage circuit breaker, and this is all about the devices. Now let us try to discuss about the first one, fuse. Now I'll show you the how an fuse is there, and we'll discuss about this one. So, so these are the different types of fuses what we generally have. First fuse is called, this fuse we use in bike as well as car. This fuse we use in our lab and stabilizers. These fuses are called used for solar plant, which is called high rupture capacity fuses. Can anyone seen these fuses? These porcelain fuses at anywhere? Please respond.
Yes, sir. Yes, sir.
Had you seen
Yes,
this
sir.
at anywhere? Where you had seen? Please respond.
These are the main circuit.
Where?
So, main switch, sir.
At the outside of your home, had you seen this fuse? Good.
Yes, sir. Yes, sir.
How many had seen this fuse? At which location had you seen? Can you say?
Beside of meter, sir.
Beside the meter. Good. And where you had seen remaining?
Motor, sir.
Yeah, very good. Motor, where you have this agriculture motors, you may have this kind of fuses. Good. Next.
Current poles.
Yeah, very good. And near the current poles, you can see these kind of fuses. Very good. Super. Next. Near to the transformer and the current poles are good. Next. Where you had seen this? At the starting of your house also it will be there. Had you observed?
Yes, sir.
Every house will have fuse.
Yes, sir.
Please observe it. Okay. So
Okay.
these fuses are called Kit Kat fuses. So Kit Kat means, so you can see this Kit Kat. You can break that Kit Kat. The same, you can insert this fuse inside this carrier and you can remove it. Therefore, you can insert and you can remove. These are called Kit Kat fuses, and these are fuses used in electrical engineering in transmission line. So explosion fuse type, do fuse type, HG fuses, okay, thermal fuses, micro fuses. These are multiple types of fuses used in day-to-day life. The purpose of this fuse is to protect the equipment as well as the from short circuit as well as from overload. Now we'll try to study about it. So now have you got a picture about how a fuse will be there?
Yes, sir.
Yeah, good. Now let's try to see about the fuses. Okay. So coming to the fuse. Okay. So those who want to write running notes, you can write comfortably now. Okay. So the basically a fuse is a protective device. This is basically a protective device which protects our life, and it will cut the extra current or the current which is abnormal. This will cut the current. Therefore, this fuse used to cut the flow of excessive current. So the short circuit current may be due to lightning or due to overload also. It will cut the current, and this fuse works on the principle of a heating effect. So this consists of a bimetallic strip. So these bimetallic strips get heated, and automatically the circuit will act as an open circuited. And this fuse consists of an wire. Here you can see here, this fuse consists of an wire. So this is nothing but that wire. So this fuse is designed, or this wire is designed with high resistivity. It has high resistivity, and it has low melting point, and this wire will not melt easily. It has a low melting point. Melting point is lower, but it has a high resistance. Therefore, it can offer, resistance is higher, it can offer the maximum current to flow through it. So how much current it can flow is, so the thickness of the wire. For example, let's take this is the wire. So the thickness of the wire, okay, this is the thickness of the wire, is directly proportional to the flow of current. This flow of current is directly proportional to the cross sectional area of the conductor. So this is directly proportional to the cross sectional area of the wire. For example, if it is 10 ampere, the wire is thinner like this. If it is 50 ampere, the wire will be little bit 5 times it is increased. So this is the thickness of the wire. Okay. So depending upon the magnitude of current, the thickness of the wire will be there. If so, the fuse will be like this. So as soon as it is designed for 10 amperes. So unfortunately, if 12 amperes current flows, this will blow off and it will make our circuit as open circuited. Okay. So now whenever this becomes open circuited, and you can replace this fuse. So we can replace this fuse. I think you know how to replace the fuse. Okay. Just remove this broken fuse and remove these two screws and insert an new fuse here and just tight it, and insert this fuse carrier into the original one, then automatically you can replace the fuse. And this comes under the examples of refusible type. You can replace the fuse. So while you replace, you have to know about what is the thickness of the current it is designed. Generally it is designed for 5 amperes, you have to use one thin wire. If it is designed for 10 ampere, you have to use two wires. Okay. So when you connect them in parallel, the current will increase. And this fuse is made up of a material which is nothing but zinc type material, or it is made up of copper, or sometimes it made up of aluminum, or it is made up of silver. So fuse is made up of these four materials. Let us try to see how generally the fuse will be available. Okay. So this is how physically a fuse is there. So here you are going to have the this is called brass and caps. So this red color one are called as a brass end caps, and here we have that element. Okay, and this is the where we have a screw here, and here also we have an screw here, and these fuses are called as cartridge fuses. So these are called cartridge fuses, and here we have the filling powder. This is called filling powder, and this is called fuse link. So to link that fuse, this is called fuse link contact, and this fuse is connected here. This material is called bimetallic material. Okay, so actually this is the fuse. So here you can see the red color one what have been connected for the clarity. So this is called fuse, and this fuse is made up of a bimetallic. I mean, two metals are added together to make this fuse, which is called bimetallic, and this bimetallic is controlled with the help of heat. I already told fuse is nothing but works on heating effect. Okay, so this is a bimetallic thermal control. It protects from overload. Okay, when you get, so why overload will occur is generally if you take mixie, we should keep minimum amount of quantity, but rather than the minimum, we'll keep up to the neck. We'll fill the things, and will turn on the mixie. Automatically it is overloaded. Whenever it is overloaded, automatically this fuse will burn, and it will give an safety that you have been overloaded the mixie, and we should remove that load in that mixer, and we have to rewire this fuse automatically. We can do it. So this is what basically called as a fuse. Okay, so now let us try to see here MCB, miniature circuit breaker. The next one is miniature circuit breaker. What is this miniature circuit breaker? Miniature means this is a small type of or a smaller size circuit breaker, and this miniature circuit breaker is a electromagnetic device. Okay, so I will show the device. No worry, just let's try to discuss. Okay, I will show it. Then you'll get a clarity. This is how an fuse seems to be. Had anyone seen this fuse in your home?
Yes, sir.
Yeah,
Yes,
good.
sir.
Can you say where you have been seen these fuses?
Yes, sir.
Where you had seen these fuses?
Beside of metal. Beside main. Beside of
Beside to your home, you had seen these fuses, right?
Yes, sir.
So now let us try to see the parts. So once let us try to see the operation, then you can understand here. Okay. So these are the different parts we have in our fuse. So please see the parts. So here this is nothing but this is connected only for the phase, not for the neutral. So for the phase, when you connect, so the first tool what we have is thermal. This is called bimetallic. I told this metal what we have in an MCB or fuse is bimetallic. So this is nothing but a thermal bimetallic strip. So when as soon as high current flows, this bimetallic strip will bend. Okay. So whenever high current flows, this bimetallic strip will try to bend automatically. So whenever which is in on condition, it will come to off condition. And this is called the tripping lever, and this is nothing but how to make this MCB on and off. Okay, and here this is called as an electromagnetic solenoid, or this is called an electromagnetic coil. And when soon as you make it off, some arc will be released, and this arc is suppressed in this arc chamber, so to control the high currents. And this is, if this will be all the time fixed, and this contact will be in closer. Whenever it is closed, automatically the switch is in on position. Whenever it is moved to up, automatically this will be in off position. Okay, so now the upper one will act as an on position, and bottom will act as an off position. So now it is in off position, means now this is open circuited or short circuited? Open circuited. Therefore you can have some gap in between this. Okay, and since it is moving up and down, it is called a moving contact. Since it is fixed, it is called as an fixed coil, and the supply what you give here will flow in this coil, and this coil is called an electromagnet or a solenoid. So this is the lower terminal. So the current flows. Now let's try to see the animation, then you can understand the things. Okay, is the animation visible? Just watch the animation. Here you can see here the different parts we are having. Okay, just once watch the animation. Once it is in off mode, the current will not flow from this point to this point. Okay, so no electricity is flowing. Now the supply is on. As soon as the supply is on, here you can see here, so this is the lever what you are going to close. So automatically this is a moving contact. The current flows from this point to this point. Okay, now this is in which condition? On condition, the current is flowing. So this top one is called lever. Okay, so the upper one is called lever, and this is a moving terminal. This is a fixed terminal. As soon as this fixed terminal is contact with this moving terminal, the current flows, and this is called solenoidal, and it will form an path. Now it is in off condition. Now by the lever, we are keeping in which condition? On condition. Therefore, the current will start flowing through the lever, and it goes to the solenoidal, and output is collected. So hope you are able to understand the videos, the thing how it operates. So here you can see this is fixed, that's why it is called fixed contact. This is called moving contact. This is called an electromagnetic coil which is operated. So now as soon as you give the supply, here you will give the supply. Okay, and the switch is in on position, and the coil which is moving, this is called movable contact. This is an fixed contact. So therefore the current starts flowing. As soon as the current gets overflow, this bimetallic strip, so here you can see here, this bimetallic strip will get heated, and as soon as you make it off, voltage will be there. This voltage will be absorbed by this arcing arrestor. Okay, so you see this operation, you can understand better. So this is the bimetallic strip. Okay, so this bimetallic strip, as soon as it gets overheated, automatically it will come to off position. Okay, and this is an electromagnet. As soon as the supply goes off, this will send the current to this arc. So this is nothing but the arcing chamber. So I will show this arcing chamber also, then you can understand in detail. Now have you seen the parts in an MCB? So what are the different parts we have in MCB? Respond. So hope you had seen the working video. So what are the different parts we have in MCB? Respond, those who are watching the class.
Upper terminal.
So which is nothing but first one is tripping lever. So this is an tripping lever is nothing but what? Bimetallic. Okay. So as soon as you make the, this is in on condition, when you make it off, suddenly voltage will be there. That voltage will be absorbed by this arc arrestor. So I had already shown a coil is there. This coil is called an electromagnet or an solenoid, and this is fixed. As soon as you move it up, so now basically this is in off condition. As soon as you move this tripping lever to the upward, automatically this moving contact will try to close this fixed contact, and the supply will start flowing. Okay, and this lower coil is called moving contact, the upper one is called fixed. Why it is fixed? It is moving, that's why it is called movable. Okay, so this is nothing but the tripping lever operation. And here as soon as you make the switch off, okay, now it is in off. So the as soon as you can see here, when you turn off your bathroom switch also, it will produce arc, I mean some spark. So the spark will be flown into this arc chamber. For this, an arc chamber is also provided. Now we'll try to discuss. Is everyone able to understand the working of an MCB?
Yes, sir.
Yes or no? Shall I show the video? You got what are the different parts? You have to draw the diagram. Is first one is fixed contact, next one is movable contact, next one is nothing but an electromagnet which is called solenoidal. So beside to the solenoidal we have an arc chamber, and the which initiates this operation is nothing but a thermal strip, okay, which is a bimetallic strip. Now let's try to draw the circuit diagram, and the same what you're seeing here we have to explain with the help of an diagram. Now let's try to discuss about this. So this miniature circuit breaker is smaller in size, that's why this is called small circuit breaker. This is a basically an electromagnetic device, and this is molded. You can see here completely it is molded in an insulated. So this complete MCB is molded in an insulating material. So completely the plastic material is used, and it is acting like a completely a molded material. It is kept inside, and whenever the fault current, for example, designed current is 10 ampere. So due to lightning, the current may be increased due to 12 amperes. Whenever the current increases in this 12 ampere, this bimetallic strip will try to bend, and automatically each way is in on position, it will try to move to off position. So that is the purpose of this bimetallic strip. Okay, and we can make it on or we can make it off. So we can make manual on of this switch, as well as we can make the manual off also we can perform. And like a fuse, we no need to rewire it. So basically this is an maintenance free, no need to maintain. Once it comes to off position, just you can make it to on, automatically bimetallic strip will be in contact. And so this MCB, if it damages, we can easily replace this from the market. Here the main component is nothing but a trip bar. So this trip bar is called as bimetallic strip. So this is nothing but a bimetallic strip, which is nothing but the trip bar. And here the main heart of this is nothing but a solenoidal, where this solenoidal is called as an electromagnet. So this electromagnet or the solenoidal is the main heart, and where this electromagnet or solenoidal will protect our equipment from short circuit currents. So now coming to the working principle, how it works. So what I had shown is nothing but animated video, but in the subject we have to draw the diagram. That's the main task. That's why we should focus on the theory also. Okay. Working. So here this MCB will work only when higher amount of current is flowing. This is called overflow current. So in order to MCB to work, we require an bimetallic strip. So there is a strip where the name of this strip is called bimetallic strip. You can see this bimetallic strip. So this is nothing but it works on the principle of bimetallic strip, and this bimetallic strip gets heated. So when you make around more than the rated current, let's try to take 10 amperes, but how much amount of current is flowing? Plus 2 ampere extra is flowing, automatically 12 amperes current will flow, and this bimetallic strips will get heated up and it will try to bend. So as soon as extra amount of current is flowing, this bimetallic strip try to bend, and it releases the lock and make the MCB2 off. Okay, so as soon as you make it to flow as 12 amperes, this will try to bend and it will make our switch to move from on position is there, it will automatically it will fall down. Okay, so this bimetallic strip will bend and automatically the lock will be breaked and it will automatically move down. And what we have to do is we have to first solve the problem for short circuit, and once again you can move it manually up, it will come to on position. So this is how it works in the case of overload condition. When you overload and mixing, this is the working function. And similarly it can work for short circuit. So what is short circuit means, here we have the phase and here we have been kept the MCB. Okay, let's try to see here. So here we had kept the MCB and here we let us try to take we had connected to the geyser. So this is our geyser and this is nothing but neutral. So MCB we had inserted only in the phase. So as soon as this geyser is overheated, the maximum amount of current will flow, and automatically this geyser will act as an short circuit. Why it becomes short circuit means due to aging. So whenever the geyser is used for longer time, so due to corrosion, the element will become as an short circuit. So whenever it is short circuited, R is equal to 0, current I is equal to V by R. So it is nothing but V by 0. And how much amount of current will flow? Infinity amount of current will flow. Wherever infinity amount of current is flowing means automatically this MCB will treat it as an short circuit current. Now how this MCB will work in the case of an short circuit current, let us try to understand. In short circuit, the current increases abnormal, where this increment of current is abnormal. Abnormally the current will increase, and whenever the current increases abnormal, then the solenoidal, which is nothing but an electromagnet, will try to operate. So this electromagnet is connected to the solenoidal. This electromagnet will try to move the plunger. Okay, so this will try to move the plunger and automatically this plunger will try to move the solenoid and automatically it will perform the trip action. Automatically your MCB goes to off position. Okay, so as soon as once the switch comes to off position, it's like this. Okay, the switch is in off position, we can make it to, so the switch is in off position, in this position we can make it on like this. Okay, so that's how we can solve the short circuit and we can restore it back. So that's how this electromagnetic relay will be operated. Now let us try to see the circuit diagram of this one. Okay, let us try to see here. Under no fault, there is no fault in the MCB, then how it works. Whenever the fault is there in the MCB, then how it works. Okay, so this is the solenoid what we have. So this is nothing but the bimetallic strip, and this bimetallic strip is connected to the latch, so it is act as a locking mechanism. So now the switch is in, no fault is there, and we are giving the supply from this side. So here we are going to take the output. So whenever there is no fault, automatically the current starts flowing. As soon as the current starts flowing and this magnetic coil, so this coil is called magnetic coil, and this will act as an electromagnet, and the same will flow here. And basically this is a bimetallic strip, and this bimetallic strip will be acting as an closed path, and the output is like this. Whenever the fault occurs, what will happen is so whenever the fault occurs, automatically this bimetallic strip will operate and automatically it will try to move down. Okay, so I will show the diagram after the fault is occurring. So this bimetallic strip will go down and automatically the output is open circuited. Okay, so this is how again it is connected to the coil. Okay, so whenever the fault is occurred, our bimetallic strip has been operated and it has been moved down. As soon as this point is moving down, the switch is operated like an open circuit. So this is called latch. Okay, the main hero of this component is bimetallic strip, which is connected with the help of an latch. Is how we operate. Now, when you see this video, then you can understand the things more better. So this is little bit tough to show the things which happens in online, and we have to show the things in offline. That's the main problem. So now we can see the things how it works. So see here, these are the two contacts. As soon as this switch, so this is in off mode. Okay, so this is an fixed coil, this is an moving coil, this is the bimetallic strip. So as soon as you keep in the on mode, this is called lever, where this is called the lever, and this is called bimetallic strip, and it will be in contact. As soon as this is in contact, the current starts flowing. Whenever the more current flows, automatically this bimetallic strip will open. Automatically it gets come to this position. So this bimetallic strip is in off condition. That's why it's here. Okay. So and the current will flow into solenoidal. This is how the circuit breaker will work. Hope everyone is able to understand the operation of the circuit breaker and how it will be in on condition and how it will be in off condition. Hope you got some clarity how it actually works. Let us have some discussion. Are you able to understand?
Yes, sir.
Is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Actually, the problem is theory is a little bit different and practical is little bit different. So you should able to match theory and practical, then only you can understand. So where you had seen this MCB
Beside the meter, sir.
beside to the meter, and in the college in your AC is there, you can see an MCB. And where you had seen this MCBs in your home? In your home, do you have any MCB?
Yes, sir. Yes, sir.
Where?
What?
Where you had seen this MCB? No one has seen this MCB till now.
Yes, sir. This one.
Yeah. Where you had seen this MCB?
So the main.
Beside to the main.
Beside the
Okay.
main.
And where? And if you see this geyser is there. Geyser as well as AC also is there. AC plug is also there. There also we have an MCB. Okay. For washing machine also we have an MCB.
Motors.
Yeah, motor, very good example. In motors also you can have an MCB. So MCB is variable or not variable? It is automatic. Okay, we no need to have revariable it. So as soon as it comes to off position, we can make it to move to on position and we can make it on. Okay, so what is the purpose of MCB?
Maintain the current.
No,
Is
whenever the
stable.
current is excess, that excess may be due to fault in the geyser or maybe a fault in the AC or maybe fault in an mixie, it will draw more current. Why it will draw more current means there may be some problem in the motor. This excess current whenever it is flowing, the bimetallic strip which was in on condition, automatically it will trip, it will fall down. Okay, and we have to remove that equipment and once again you have to keep it in on condition, then automatically it will be restored. So now we will discuss about one more useful component, which is nothing but RCCB, which is a very good, powerful device. This device is really, I have been discussed with you earlier. Now we will try to see how many coils are there and how it will work. Okay, hope you got a clarity. Yes or no? So
Yes, sir.
for the
Yes,
exam,
sir.
for the exam,
Yes, sir.
if the question examiner is asking, then you have to draw this diagram. You can't draw this diagram, why? Because this is a 3D diagram, so you should draw this diagram. Okay, so the diagram what I have been drawn, so this diagram you have to draw. So neatly it is there in the material, and I will circulate this material. By this material you have to draw it. Okay, so take small break. With the last topic we will close this unit, earth leakage circuit breaker. Okay. Okay, shall we continue the class?
Yes, sir.
Okay, good. Thank you
Yes,
for
sir.
your patience. So the strength is too low. What is the reason? Okay, shall I continue?
Yes, sir.
Yes, sir.
Okay, thank you. So now we will discuss about, one second. So now we will discuss about this RCCB. Okay, so which is nothing but a residual current circuit breaker. Okay, so how this RCCB will work and what are the function of this RCCB and how it is useful to protect the life. Okay, first let us try to discuss it parts and we'll go into the hardware. So basically these RCCBs are of two types. Basically they come under the example of earth leakage circuit breaker. So these there are two types of circuit breakers which are under earth leakage circuit breaker. So first one is this earth leakage circuit breaker will identify the leakage current which flows in the body of the geyser. Okay, so when you have the geyser, so this is nothing but the geyser. So we had connected the phase and we had connected the neutral, and this geyser is connected to the tap. So as soon as the geyser becomes aged and the phase will also will flow in the geyser, and water will come out of the tap. In this tap what is there is a current is there. So whenever a human being is going to take the bath, whenever he touches this water coming from the tap of the geyser, automatically the current flows into his body and there is a chance that this human being is going to die. So in order to, so we want to stop this leakage current. I mean, whenever this leakage current is flowing, automatically we have to trip this phase and we have to protect the life of the human being. That is actually done by an earth leakage circuit breaker. So this earth leakage circuit breaker is designed such a way that the leakage current, whenever the leakage current is flowing through the metal body of the material, I mean metal body or through water it may flow. This we have to arrest. And one more example we can take, which is nothing but fridge. So fridge is made up of what? Metal. So completely this is metal. So whenever the human being is opening the door of the fridge, so this fridge is also connected to the phase and is also connected to the neutral, and the phase inside the motor due to any short circuit, the voltage will start flowing into the metal part. As soon as you touch this metal part, the current will flow into your body where this current is called leakage current. Whenever this current is 30 milliampere, you will get heart attack and you will die. Okay, so now we want to protect our life from fridges and we have to protect our life from geysers. How we are going to do, let us try to discuss. So all this we can protect our life by using earth leakage circuit breaker. So now how to restrict this leakage of current, we need to understand. Okay, so basically if you use MCB or if you use basic circuit breaker or if you use fuse, they cannot identify this leakage current. They can identify only the short circuit current and they cannot identify this leakage current. Okay, so therefore we have to remove the, we have to identify the leakage current only which is possible with the help of an earth leakage circuit breaker. So there are two types of earth leakage circuit breaker. One is voltage operated, so voltage operated earth leakage circuit breaker. Next one is current operated. Okay, so next one is current based on the magnitude of current operated earth leakage circuit breaker. Okay, so this ELCB is called voltage operated and current operated is called it's called current operated ELCB. So this is nothing but that ELCB, which is nothing but we call it as RCCB, and here it is written here it is nothing but PRCB plug. Okay, so portable residual current circuit breaker, and this is from the brand Evil. So here you can see here, so this is a reset button. So if you want to make it on and off, you can do it. And here we have an test button. This now we will discuss how the construction is there. So basically, why an human being will die? So please unmute your mic. Let's have an like an interactive type of learning where your doubts also will be clarified. So human being will die due to voltage or current?
Current.
Current, good. So that current is called leakage current. So people will not die due to, people will think due to voltage we are dying. We are not dying due to voltage. People will die only due to current. So let's try to understand how much is the maximum amount of current. If it flows, we will die. Okay, so there are some levels of current where human being will not die, where there are some side of current, when this current exceeds, automatically human being will die. Let's try to see those currents. So first one is, let's try to write down the table. Leakage current, magnitude of leakage current, and what kind of field the human being is going to have. So first one, if 0.5 milliamperes of current is flowing in your body, for example, you have a fridge. Okay, so this is your fridge, and this is the human being, and this human being is touching the door of the fridge. Okay, and this fridge is connected to the face as well as neutral, and in his body, if 0.5 milliampere, and he is connected to the ground, in the bare foot is connected to the ground, then automatically the current will not flow in this body. Why? Because due to some malfunction, this will directly flow into the body and it will make the damage to the human being. But people will not die. Some cases only people will die, and the remaining cases the people will not die. Why they are dying? Where they are not dying? Let's try to see with an example. So if the current in his body is only 0.5 milliampere, he'll be having a slightly tingling sensation. So this is called slight tingling sensation. Like if someone you beats on the back, or you take a small needle and if you press on your hand, you'll have a small tingling sensation. So this, due to this 0.5 milliamperes, the people will not die. So now let's try to understand. Due to the person has touched the fridge with more contact area, then he will have an mild shock. So mild shock means he will not die, and he will be thrown away from the fridge. That's called mild shock. And assume that this person is in wet. His uh, foot is full of water, and he has been touched in the more contact area. And assume that he is acting like an resistor. Then 5 milliamperes current is flowing. Then he will be having a painful shock. So he is going to have an painful shock, and the person also will not be in control. He will lose the loss of I mean, there's no control on his body, and here he will not die. And this current we can allow it to flow, where this current we are going to call it as a let go current. Okay, so he will receive some shock, and a small burning will be there on the hand, and he will not die up to 5 milliamperes. Now the person is wet, and he has been touched the door, and the contact area with the door and his hand is more, and more current will flow into his body. Therefore the current level is increased to 10 milliampere. Therefore the muscle will start freezing. Okay, the muscle starts freezing. So when muscle gets flawed, gets freeze, then this current is called let go current. So muscle freezes means he has been 100% subjected to shock. Definitely he will die. In this case of 10 milliamperes is flowing. If this person is touching this fridge with more contact area, and he is standing in the water, or he is standing with more amount of contact with the water, and automatically more 30 milliamperes current will flow. Definitely here he is going to have heart attack, which is called respiratory paralysis. Okay, so now he is going to subject with an respiratory paralysis. So he will get electric. If you get paralysis, the person will start shivering. So whenever the person touches this fridge which is having faulted, then automatically he will also shiver, and his muscles gets contracted. So still he will not die. Okay, so now fridge is there, and this person has been in contact with the faulty fridge, and let us assume that he is allowing the maximum current to flow through his body. If the maximum current is flowing through his body, means what is the resistance offered? Zero. Okay, very very less amount of resistance, is offering, maximum current is flowing. Therefore current I equal to V by R is offering less resistance, then automatically maximum current of 100 milliamperes will flow. Therefore here he will get heart attack, which is called heart failure. And this heart failure is called massive heart attack, which is called ventricular fibrillation. This is called ventricular fibrillation, which is called heart failure. The heart will stop working. Definitely, he will die if this amount of current is flowing. If more than 100 milliamperes is flowing, then he is going to have cardiac arrest. So, massive cardiac arrest within 1 second, he will die. So this is called cardiac arrest, and complete the skin will start, the severe burns will be there. Okay, so this is all the magnitudes of current. Sir, why different magnitudes of currents are there? Okay, so this is a faulty fridge. Okay, and the person is there, and he is wearing some shoe. Okay, if he touches this faulty fridge, which is having the face is connected and neutral is connected, if he touches, the shoe is there. So whenever shoe is there, automatically current I equal to V by R is offering more resistance. Automatically current is minimum. That's why in the lab we instruct you wear the shoe. When you wear the shoe, the resistance is greater, the current is minimum. If the current is minimum, just some tingling, it will throw you out just by muscular contraction. So still you are not wearing the shoe, automatically sometimes the people on the home will be with a wet bare hand and bare legs, they will be standing on this, and they are offering a resistance current I equal to V by R. They are offering the maximum current to flow through them where the resistance is lower, the magnitude of current will increase. Let's try to increase the current to 5 ampere. They will have small shock and your hand will be pulled out from this. And if he is too wet on the land and he is in contact with the fridge more, a complete hand is in contact with the fridge, automatically you will get heart failure. Definitely he will die. So how many of these those who are listening the class has got electrical shock?
No, sir.
No one.
No, sir.
No.
No, sir.
Yeah, good. So no one has received any electrical shock, means you are offering high resistance or low resistance till now. How much
High
amount of
resistance.
resistance? You are offering high resistance. Therefore, the current is not flowing in your body. That's why we instruct you to wear what? Shoe. But some people will be getting electric shock, but they will not die. Why they are not dying means their current flow is less than how many amperes? What is the amount of current flow in their body? Less than 30 milliamperes. That's why still they are living on this earth. If they are very they have wet shoe, I mean wet, they are in standing in wet, and they are in wet condition and they are touching this faulty fridge, automatic the current level will increase. Definitely heart failure will happen. Okay, if the leg is too wet and they are having in contact with these faulty devices, definitely they will die. But there is no issue that. So this is called as a is it visible? Is it visible?
Sir.
So
Yes,
this
sir.
is called RCCB. The plug is like this. This is to connect to the connector, and here we have to connect the load. Okay, and here if you keep this, you keep this in the supply and keep this plug in your mouth also, you will not die. Why? Because this is designed to, for example, this fault current is flowing, okay, around 30 milliamperes is flowing. So this will not flow into your body. Why? Because this automatically it will start tripping. Okay, so this will start tripping. Are you able to see the rating? So this is an 6 amperes plug and this is manufactured by Evils. And what is the voltage rating you are seeing on this device? See the current rating and say me the value. Huh? How much? 30. Very good, Kavya. 30 milliamperes. 30 milliamperes means how much current? It's like respiratory issue will get, and definitely this device is going to protect. What is the name that's written on this device? Life.
Savior.
Very good. Life savior means what is the meaning?
Which
It
protects
protects
the life.
from electrical shock. How many buttons indicators are there on this? One button name is what? Power button. It will glow.
Power button.
Another button is what? Test button. So this next button, as soon as you press, automatically it will isolate. Okay.
Hello?
So this is how it works. And what is the name of this switch? It is written as what it is written. What is the name of this switch? What is the name of this switch? I mean, name of this device. PR.
PRCD.
PRCD means, can anyone can expand? P means portable. So this is easily you can move from one place to another place. P means portable. RCD means residual current device. So this is a small device. Therefore, this is called portable residual current device. This will help us in protecting the life of an human being. So if you connect this to fridge, never you will die. When you connect this to a charger, never you will die due to an electric shock. So without many don't know this appliances is there or this device is there. That's why the people are dying. If this kind of devices is there, no farmer will die, no children will die, and no those are not aware of electrical shock also will not die. Do you know many people will die? Those are operating computers. So if you have your laptop or computer, if you insert a metal pen drive to your USB port, also you'll get shock. Have you observed? So
Yes,
those
sir.
kind of things also we can stop by using this PRCD plugs. These are very very powerful plugs. Okay, so this is the importance of the plug. Now let's try to see the circuit diagram how this PRCD plug will work. Okay, so now you got a clarity what is RCCB or PRCD plug. Both are same. RCCB means residual current circuit breaker. Since this is movable or portable in nature, this is called portable residual current device. Okay, now let us try to see how this RCCB will work. So this RCCB, let's try to see the working of this RCCB. RCCB is a part of ELCB, which is nothing but earth leakage circuit breaker. So coming to this RCCB, what is RCCB? Can anyone expand? Residual current circuit breaker. Residual current circuit breaker. Residual means some remaining current or left current is called residual current. Okay, so this RCCB will use a, what inside this is, it will use a small current transformer. Okay, it will use a small current transformer, and it is having a live wire. That live wire is called line, and it consists of an neutral wire. So to this live wire, one coil is there. This is called first coil, and the neutral also one more coil is there, which is called second coil. And there is one more coil which is called sensing coil. So there is one more coil which is called sensing coil, that is connected to the this sensing coil is connected to the trip coil of circuit breaker. So let us try to see what happens in normal case. Okay, so the circuit diagram for our RCCB is like this. Okay, so here we are going to have the line, and here we are going to have one solenoid, and from here it is connected to the coil, and it is connected to the load, and from output of the load once again it is connected to our coil, and it is brought back. So this is the neutral connection. So this is given an input of 230 volts single phase supply and 50 Hz, and there is one more coil. So just one second. So let us try to see the parts until this computer get restored. So these are the different parts we have in an RCCB. Okay. Okay. So when you open this RCCB, so these are the parts you can observe here. So this is called tripping circuit, and this is called a trip resistor, and this is called as an relay circuit, and this is called a solenoid. Okay, and you can see the one more diagram also. So when you open this RCCB, this is originally a physically an RCCB is there. These are the two contacts at the bottom, and this is the switching, which is nothing but the operating mechanism. At the top, we have an test button, which is available here. So this is the operating mechanism, and this is a permanent magnet relay. I will show you the diagram, and whatever I have been was drawing the diagram is about this current transformer. It will have primary, secondary, and neutral, and this is going to have the movable contact which make us open and close, and this is how a physically an RCCB is there. So this is a portable PRCD plug. Okay, so let's try to get the diagram such a way that you can get an clarity how to draw the diagram. So just 1 second. Yeah, good. So sorry for interruption due to the computer has got overheated. So here we have line. So you are going to have the one more coil. So this coil is getting connected to the relay. Okay. So here we have an relay, and this relay is connected to the two terminals. Okay. So here the yellow colored one is there, and this connected to our coil. So like this it is connected, and this relay is connected to this trip circuit. And how many coils are there? So let us assume that this is an line current. This is IL, okay, which flows in this, and the current which flows in this neutral wire, I'm going to call it as IN. Okay, so the name of this coil is called as a residual current sensing coil. So the name of this coil is coil number 3. This coil is designed to identify the residual currents which are flowing or the remaining currents, and this coil is called residual currents sensing coil. And here this is our geyser. Okay, so this is basically our geyser, or let us try to take this is our fridge, and this fridge is connected to the earthing point, and here also we have earth point which we have connected. In the class we'll discuss about this importance of earth point. Earth points are connected. So here as soon as the current in this coil is called as a residual current. So as soon as, for example, let us assume what happens in the normal condition and faulted condition. Okay, so in the case of a normal condition, what happens here is in the case of a normal condition, the residual current is given as a, so the residual current is equal to IL minus IN. Okay, for example, so IL minus IN. Okay, so let us assume that in this IL, I mean, actually, this is a current transformer. Some current of 1 amp may be flowing, but it will be reduced in the current transformer, and it will be indicating as 40 milliamperes of current is flowing in the IL. So IL is carrying how much amount of current? 40 milliampere. The same current will flow into the load. The same current also will flow in the neutral. In the neutral also, both are connected in series. The same amount of current is flowing. 40 milliamperes minus 40 milliamperes is how much? 0 milliampere. Whenever the current is 0, the residual current that is produced by this residual coil will send a signal to the relay, and the circuit will be in on condition only. So the circuit is in on condition. There's no current or EMF induced in this residual coil, and the relay will not do any work, and the circuit will be in on condition. So whenever what happens is so whenever the human being is there, okay, so an human being is there, and he is on barefoot, and he is on wet condition, and he has been uh, in contact with the fridge. Okay, so whenever the fridge is contact with the fridge and he is in barefoot, automatically in this 40 ampere around, assume that and 30 amperes of current is flowing in his body. Okay, so this guy is very not clear about what he is doing, and he is sitting here, and he is on wet hand, and he has touched this faulty fridge, and 30 milliamperes current will start flowing. So in 40, 30 is flowing in his body. So and here it is his heart. Okay, automatically it will flow through his body, and definitely he will die. And 40 is entering 30, he has been observed. How much will flow here? Only 10 milliamperes will flow. So therefore, the formula of residual current is IL minus IN. So what is the IL value which is flowing in the circuit is 40 milliampere minus what is the IN current, the neutral current, 10 milliamperes. So what is the amount of current that is flowing in the residual coil is 30 milliampere. So this 30 milliampere current will flow, and it will produce some flux. Due to this flux, this coil gets energized, and automatically residual current of 30 milliamperes will initiate this relay, and the trip will perform off. And whenever it pops up, automatically the human being is safe. That's how the human being will be protected. Okay, so the residual current will generate residual flux. Okay, so flux is equal to N into residual current by R. So residual flux is generated, and this flux will generate some EMF, and this EMF will make the relay to come to which position? Off position. So this is how actually and RCCB will work. Now this is how this RCCB will protect your life also. Okay, so that's why it is designed for 30 milliamperes. Okay, so it will not make the human being to die, and it will protect your life. That's how what I told the test button. This is the test button. What is there? So here the test button is not drawn. Why? Because it will create a confusion to you. A small test button also is available here. Okay, so I will draw it before you'll get a clarity. So a small button is there. So a small button from the neutral. So from here, a small button will come, and this is connected to an trip button. This is called trip button, and from this trip button and resistance is there, and it is connected to the line. Okay, so here also we can create a fault whenever we create a fault, and when you press this trip button, you can see this trip button. So at the top, is it visible? Trip button, red colored one, is it visible or
Yes,
not
sir.
visible? This
Yes,
red,
sir.
this is called is the sound also visible, audible?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
So this trip button, when you press it down, okay. So now you can see here, I am pressing this trip button. As soon as you activate this trip button, rather than a human being, the current will start flowing into the trip circuit as 30 milliampere. This is line, this is neutral. 30 milliamperes current will start flowing automatically. You can see here this reset button will go down, and automatically it will trip the circuit and it will protect our life. Okay, so very simple to understand. So here two currents are there. One is residual current. Residual current is if it is healthy. Line current is how much? 40 milliampere. I mean neutral current is how much? 40 milliampere. Therefore the residual current or the remaining current, I mean residual means the remaining current. So residual means the remaining current is 0 milliamperes. Since the residual current is 0, the switch will not be in healthy condition or off condition. Whenever fault is occurred, human being is touching, or we only trying to test this button with this button. When you press it, automatically this will consume 30 milliampere, and automatically the switch will come to off position. Whenever it comes to off position, we are getting safety to the human being. Okay, so this is all about RCCB working. Okay, so hope is it clear? So
Yes, sir.
thank you for your time. So this is the end of our class. So we had given you the required clarity what actually an RCCB is. Okay, so how many types of RCCBs are there? Please everyone
Two types.
Two types, sir.
turn on your mics. What
Two
are those
types.
two types of RCCBs?
Voltage operated.
Very good. Voltage operated ELCB. ELCB
Current
means
off.
Current operator.
that's okay. Very good.
Current
What is
operator.
ELCB?
Get the leakage circuit breaker.
So this is what we are studying. Okay. So you may get doubts are how we can understand these many things. There is no solution in my hand. Okay. The same questions you'll get in the exam. Are you able to understand the logic to what I'm concerned?
Yes,
Yes,
sir.
sir.
Whether it is tough or easy, definitely you should crack the exam. No one will help you out. Is it clear?
Yes,
You
sir.
should understand the concept, you should draw the circuit, and you should pass. No one will help in this aspect. Is it clear? So those who are
Yes, sir.
listening, it's good, you will pass. Those who are missing the class, it's also good to them. Why? Because they may fail and sometimes they have to study again. Okay, so everything is in our hand, whether to pass or whether to fail, everything is there in your hand. I'm just an helping you to make you pass. Other than this, it's not any other thing. Okay, so it may be tough for you to understand, but there's no solution. What is the next part we have? I mean, what are the different currents we have? What are the remaining currents we have? So for 0.5 milliamperes, do we die?
No, sir.
No, we will not die. Okay, so for 0 to 5 milliamperes, we will not die. For 1 milliampere, do you die? No, it's like
No,
a
sir.
small shock. For 5 milliamperes, do you die? No, just
No, sir.
it will give shock and it will throw you out. It's called a painful shock. For 10 milliamperes, do you die? No. అంటే ఇప్పుడు షాక్ కొట్టిన తర్వాత కొంత దూరం వెళ్ళిపోయి పడిపోతుంది. Had you seen? So after receiving the shock will pull you out. That's called muscular freeze. But when you go with 30 milliamperes, it's called heart attack, which is called heart failure. How many coils are there in RCCB? First coil is called IL. Second coil is called IN. Third coil is
IN.
called residual current sensing coil.
Sensation part.
And one more button is there where this is called test button. Okay. So when this residual current will flow, if it is neutral current and line current are same, it will not trip. Whenever neutral current and line current are different, automatically it will trip. So hope the maximum help what I can do from my end. I had taken the classes and I had tried to close the maximum syllabus to the maximum extent. Hope this is the end of third unit. We have grounding techniques that we'll discuss in the normal classes, and we'll start our electronics part. So thank you everyone for your valuable time. Thank you for listening and making you to understand the things. Okay. Anything to discuss? Yes. Anything else to discuss? Okay.
No, sir.
Hope everyone has understood.
Yes, sir.
Okay.
Yes, sir.
Yeah. Thank you for your time. Thank you for listening patiently. We'll meet in normal
Yes.
classes again. Okay. So I will not
Thank you for
repeat.
your time
Yeah.
also, sir.
Yeah. I will not repeat this again in the class. So those who had listened, you explain to your friends. If they are able to understand, it's well and good. Why? Because we have less amount of time. Okay. So thank you for your time. We'll meet in the normal classes. Thank you.
Attendance.
Now I will take attendance. Very interesting.
Yes, sir.
Yes, sir.
Say roll